You got test prep section 1.3 asymptotes. We're supposed to evaluate this limit, cosine of x over x, as x approaches 0 from the right. So here's what I'm going to do. I'm going to rewrite this so that it's the limit as x approaches 0 from the right of 1 over x times cosine of x. Well, the limit as x approaches 0 from the right of 1 over x, I'm going to focus on what that graph looks like. From memory, it's a parent graph. Hopefully you remember it as well. It has a horizontal asymptote at y equals 0, has a vertical asymptote at x equals 0. And the curves look like this. So as we approach 0 from the right, y is going up forever, it's approaching infinity. Cosine of x, what is that approaching? Well, as x approaches 0, that's saying what is cosine of 0? Cosine of 0 is 1, so it's infinity times 1, which is infinity. Why is cosine of 0 1? 0 degrees is on the positive x-axis. At that point, the x value is any positive number. The y value is 0. The r value is going to be the same as the x value. Cosine is x over r. 1 over 1 is 1. There's problem 1. Number 2. Which of these functions grows the fastest? Well, we learned in class that exponential functions grow faster than other types. Each of these are exponential functions based upon the leading terms that you see here. Leading term means the term that's going to help it grow the fastest. So all of those grow faster than u to the 100th. So then to decide which of A, D, E, or C grows the fastest, look at the base of the exponential function. This is a half. This is an E. This is a 3. This is a 4. C, therefore, is going to be the answer. It's going to grow the fastest. Don't get confused by this 200. That's a coefficient. That is not being raised to an exponent. That is number 2. Number 3. There's a lot to take in for this. Let's read it and try to see where we can focus our attention. Consider the functions f of x equals 1 over x, as long as x doesn't equal 0. And g of x equals x sine of 1 over x, whereas x doesn't equal 0. Which of the following describes the behavior of f and g as x approaches 0? Well, I would examine each of these functions separately before I look at any of the answers. So we have the limit. I think I need a new stylus. The limit as x approaches 0 of 1 over x. We've got to examine that. We have to examine the limit as x approaches 0 of x times sine of 1 over x. First one's pretty simple, if you remember the parent graph. This has a horizontal asymptote at y equals 0, vertical asymptote at x equals 0. The curve looks like this. Well, if we approach 0 from the left, it's going to negative infinity. If we approach from the right, it's going to positive infinity. Those are different answers. The limit does not exist. So at this point, we could look at the answers, and maybe we already know the correct answer. A says, as you approach f, this is f by the way, it's supposed to be 0. It's not the answer. It's supposed to be 0. That's not the answer. E says that it's approaching infinity. Well, it only approaches infinity from one side. It has to approach it from the same side to be the same thing. So we've eliminated A, C, and E. If you didn't know how to finish the problem, you now have a 50-50 opportunity to get it correct, because it's either B or D. Let's examine and see if it's B or D. This is going to require quite a bit of work. We're going to use the squeeze theorem. Since I don't know how to do this problem, and I'm not just saying that, I really don't, I'm going to use the squeeze theorem. So this is going to be work for this. We'll come back and finish that up there. Sine of any angle, 1 over x, that just means any angle. If you remember your parent graphs, sine is always between and including -1 and 1. It looks like this. Forever and ever, the left and the right looks prettier than that. It goes up to 1 and it goes down to -1. This is not a perfect graph. Looks, something like that. So no matter what this angle is, the answer is always between 1 and -1. Well, we have to take this equation, this inequality I should say, and we need to put into it this x. So to do that, I'm going to multiply the left, the middle, and the right of this inequality by x. It's going to be -x less than or equal to x sine of 1 over x, which is less than or equal to x. The squeeze theorem says that if I take the limit as x approaches, in this case, 0, and if this function and this function both approach the same answer as x approaches 0, then this middle function is being squeezed together and it's approaching the same thing. So here's what we're trying to figure out now based upon that. What is the limit as x approaches 0 of -x? What's the limit as x approaches 0 of x? If those answers are the same, then this middle approaches the same thing. It's the squeeze theorem. Well, if I put a 0 in for this, I'm going to get -0, which of course is 0. Over here, if I put a 0 in for x, I'm going to get 0, which of course is 0. So since both of those are approaching 0, therefore we can conclude from that that the function that's between them, this inequality, this is between them, the limit as x approaches 0, the function that's between them must also approach 0. Keep messing that up, I'm sorry. I'm not crazy, I'm just a little tired. So that means that when we come up here, we're saying that this is equal to 0. So now, since B and D both are saying f of x doesn't exist, we now look at g of x, and we're saying that g of x, which is what sine of x, it's x times sine of 1 over x, that's approaching 0, then that leaves only one possible answer, which is D, because B says that g doesn't exist. Number 4, suppose that g of x is sine squared of x times the square root of x to the 6 plus 4, and the limit of g divided by f as x approaches infinity is 0. Which of the following could be true of f? Well, examining this part here, if x is approaching infinity and the answer is 0, x approaching infinity means we're looking for a horizontal asymptote. What's the end behavior of the graph as you go to the right forever? It says it's approaching 0. So for that to happen, for there to be a horizontal asymptote at x equals, at y equals 0, that must mean that the denominator grows bigger than the numerator. So in this problem, we're told that g of x is the numerator. We have to have a denominator that grows faster than that. Looking at the numerator, what's going to cause it to grow fast? Well, trig function sine doesn't cause anything to grow fast. regular trig function sine goes as high as 1 and it goes as low as 0, and when it goes to the right it just keeps oscillating up and down, back and forth. The second part here, if we focus on just the exponential part, not the exponential part, the x to the 6th part, the square root of x to the 6th is x cubed. So really, g of x, the part that affects its growth, is x cubed. We want to know what the denominator would be to make that goes faster than that. X doesn't grow faster than that, neither does x squared, neither is x cubed, neither is natural log of x, but x to the 4th could be the denominator because that makes it grow faster than the top. Number 5, which of the following statements are true for this function? Let's look at our options. Option 1 or 2 we're talking about horizontal asymptotes. Option 3 is talking about a vertical asymptote. So why don't we find the vertical and horizontal asymptotes to this and see which of those statements are going to be true. As far as horizontal asymptotes are concerned, we compare the terms that make this numerator and denominator grow the fastest. The denominator in this case grows faster than the numerator because 2 to the x grows faster than x cubed. If that grows faster, that means there's a horizontal asymptote at x equals 0. Pardon me, y equals 0. Horizontal is y. So we know that 2 is correct. We know 1 is not correct. So any answer that mentions a horizontal asymptote at y equals 1, or the answer 1 I should say, automatically wrong. So now we're left with parts B and C. B says 2 is correct. C says only 3 is correct. Well, we know 2 is correct. We're not stupid, so it has to be this. Just a note to show why 3 isn't correct, has a vertical asymptote at x equals 0. To be a vertical asymptote, set the denominator equal to 0 when we solve it. Of course, that's after you factor and cancel, but this doesn't factor. An exponential function, this has no solution, by the way. An exponential function has a horizontal asymptote at y equals 0, and it goes up forever. It never touches y equals 0. Therefore, it is impossible for this 2 to the x to equal 0. So, B only. Which of the following has both a horizontal and vertical horizontal I don't know what I just said, but it didn't sound right. Has both a vertical and horizontal asymptote. Let's pick out some easy ones. Tangent of x from pre-calculus looks, let's not get real specific, looks like this. And there's a bunch of vertical asymptotes. There's no horizontal ones. To find vertical asymptotes, you have to be able to set the denominator equal to 0 and solve it, which we can do for this one. So we would have a vertical asymptote at x equals 0. If we set this denominator equal to 0, you're going to get x squared plus 2 is 0. If you try to solve this, you're going to end up with an undefined number, because the square root of negative 2 is going to be I square roots of 2, plus or minus I square roots of 2. We're looking for vertical asymptotes that are real, not imaginary. So this doesn't have a vertical asymptote. So far E does for sure. Let's look at D. Keep in mind for each of these you should factor it first and see if things cancel. This numerator doesn't factor, nothing cancels, doesn't factor, nothing cancels, doesn't factor, nothing cancels. So factoring for this problem is pointless because none of them factor. So solving D, vertical asymptote, we're going to get x squared is 2 going to get x is plus or minus square root of 2. So it has a vertical asymptote. So far, E does, D does, B doesn't, C doesn't. What about A? If we set that denominator equal to 0 and try to solve it, you'll find that there's no solution. E to the 0 is the same as 1 over e to the x. If I subtract the 1 from both sides, then multiply both sides by e to the x, divide both sides by -1, we end up with this. Exponential functions, unless there's some kind of translations, have a vertical asymptote. That's not true. I think I did this other one wrong a little bit ago. Exponential functions have a horizontal asymptote and grow like this. Notice that function, none of it's below the x-axis. There is no way to get a negative value out of that. So it's impossible for your exponent to take your base and make the answer negative. Cannot happen. So that has no solution. So that means that doesn't have any vertical asymptotes. So D and E have vertical. Which of those have horizontal? To have horizontal asymptotes, the denominator has to grow faster than the numerator. This grows faster than this. This does not grow faster than this. Therefore, D is the only one that has a vertical and horizontal asymptote. Number 7, we have this function. It's a piecewise function. We're supposed to find the asymptotes for it. Let's focus on the top function first. This would be pretty simple for us. X squared plus 2x plus 3 over x squared minus 1. To find vertical asymptotes, I think you'll find that those are going to be at x equals plus 1 and -1. That's because you set your denominator equal to 0 and you solve it. You get plus or minus 1. Now we have to examine our answer with what the domain is. The domain is x is greater than or equal to 0. -1 is not in the domain. Since that's not in the domain, that's not part of the answer. So we know there's a vertical asymptote at x equals 1 that eliminates A, B, eliminates A and B. Horizontal asymptote. If the function you're given is a rational function meaning the numerator and denominator are polynomials, the end behavior is the same if you go to the right and the left. I'm 98% sure that that's correct. 98% is good enough for you. So if that's the case, the domain has no effect on the horizontal asymptote because it's the same if you go to the left or the right. Well, examining the leading terms, they're growing at the same rate. Therefore, the horizontal asymptote is y equals 0. Scratch that. That's not true. The horizontal asymptote is a over b, which is 1. Lead coefficient divided by lead coefficient, so it's y is 1. I apologize for the 0 comment. That eliminates none of the answers, because all the answers have a y equals 1 in them. C, D, and E, anyhow. So the determining factor of this problem is going to be the second function, and the second function, believe it or not, you'll probably believe it, gave me lots of trouble today. I think I got it figured out. Let's check for vertical asymptote of this other function. Typically vertical asymptote's pretty easy to figure out. I take the denominator and I set it equal to 0. This function cannot be solved. So for e to the x equals 0, we're saying that y has to equal 0. But that's impossible because this is an exponential function that looks like this with a horizontal asymptote at y equals 0. Graph never touches it, therefore it's impossible for there to be an x value when y is 0. So there's no vertical asymptote for that. So with that in mind, since we know there's a vertical asymptote at 1, but there's none any other place, that means that we can eliminate this as an answer and this as an answer, because the only vertical asymptotes we have are from this fella, which is x is 1. Now let's do a little bit more to show why C is the answer, even though we've eliminated D and E. If you were taking a test and you were pressed for time, you would just skip the rest of it because you know it can't have a horizontal asymptote. I'm sorry, a vertical asymptote at -1. This next part's really important. It's the part that gave me trouble. Talked over with my beautiful wife for a while, and we concluded the following. So looking for the horizontal asymptote for this. This is the function f of x equals x over e to the x. I stated at the beginning of the problem that a polynomial divided by a polynomial, a rational function, the end behavior is the same as you go left to right. This is not a rational function. The denominator is not a polynomial. So what does that mean? That means the end behavior as you go to the right can be different than the end behavior as you go to the left. The end behavior we want to look at is to the left because x is less than 0. So to find if there's a horizontal asymptote in the domain that we're looking for, we have to find the limit of x over e to the x as x goes to the left forever because our domain is x is less than 0. So let's see how this shakes out. We can't just say, well, look, the bottom's growing faster than the top, there's a horizontal asymptote. There is a horizontal asymptote. It's at y equals 0, but it's not as you go left forever. It's only as you go right forever. I'm going to try to show that to you now. Using substitution. Keep in mind this is not algebraically correct, but the concept behind it is correct. Because you can't substitute an infinity into a problem. But let's do it anyhow. Let's get crazy. It's going to be negative infinity over e to the negative infinity. E to the negative infinity, if I want that to be a positive exponent, I'm going to put that, reciprocate it, and put it on the top of the fraction. Well, negative infinity times e to the infinity, whatever that is, that's not a number. For a limit to exist, it has to be a number. This is not a number. It does not exist. Therefore, horizontal asymptotes. Well, this is not a therefore yet. Horizontal asymptotes describe the end behavior of the graph. This particular graph here, we want the end behavior as x goes left forever. We found out as x goes left forever that there is no end behavior as far as it approaching a number. It doesn't exist. That means that this function has no horizontal asymptotes, which further confirms that the vertical and horizontal asymptotes only come from the first function, the top one. If the function f of x equals this hot mess has a horizontal asymptote at y equals 2 and vertical asymptote at x equals a, then what's w minus a? So, here's what we know. In order to have a vertical asymptote, the denominator has to be set equal to 0. What else we know is we are told this vertical asymptote is x equals 0. This is the part that I ignored. It's pretty important. and I ignored it and focused on something else. So if I replace each of the x values here with 0, because we know that's the solution, because we're told it's the solution, we end up with e to the 0 is 1 minus w times 0 cubed is 0 plus w equals 0. We end up with w equals negative 1. Once we know that, it's going to make this problem much, much easier than what I was trying to do before. To find the horizontal asymptotes, we compare, see if the numerator or denominator is growing faster. We're told here this has a horizontal asymptote at y equals 2. So if I compare the coefficients that have the same exponents, which are here and here, yes, I'm ignoring the e to the x. I do not know how that factors into this, so I'm ignoring it. So negative a over negative w, that has to equal 2 because we're told that y equals 2. And we just figured out what w was. W is negative 1. So we have a negative, negative 1. A negative, negative 1 is 1. Multiply 1 by both sides and you get 2 equals negative a. Therefore, a is negative 2. Finally, to answer the question, which is w minus a equals. W minus a equals negative 1 minus a negative 2, which is like negative 1 plus 2, which is 1. That is the answer C. Number 9. This one is quite complicated. What are all the horizontal asymptotes of this graph? So when I first looked at this, I thought, well, this is easy. These are growing at the same rate, so I use the coefficients. The coefficients are 1 and 1. The coefficient of 2 to the x is a 1. Coefficient of negative 2 to the x is negative 1. So the answer has to be negative 1, which is one of the answers, A. It's not the correct answer. Here's how this has to be approached. We need to look at two things. We need to look at what happens to this function as we go left forever, we need to look and see what happens to this function as we go right forever. Why? Because moving left to right forever means you're finding the horizontal asymptotes. That's what it means. So, if we were to put negative infinity in here for our x's, which mathematically you can't do, but the concept is sound, mathematically it isn't. I'm going to do it anyhow, just to show you what this simplifies to. If you don't want a negative exponent, you reciprocate the base. This is going to be 5 plus 1 over 2 to the infinity over 1 plus 1 over 2 to the infinity. So we discussed earlier, if the denominator is approaching infinity of a fraction, and the top's just hanging out like this 1 is, that means this whole fraction is going to approach infinity. This whole fraction meaning this whole fraction and this whole fraction. End up with 5 plus 0 over 5 over 1 plus 0. Therefore, this is going to be 5. Let's say again why we did this. When the problem asks, what are the horizontal asymptotes? It's asking for the end behavior. As this function goes to the left forever, the y value is getting closer and closer and closer to 5. That's one of our answers. So that tells us the answer is either E or C. I guess I won't do that. I'll cross these off. 50-50 shot at this point. So now let's look at the same problem and see what happens as it goes to the right forever. Now the problem I have is if I put infinity in for this, that's going to be 5 plus infinity, and the denominator is going to be 1 minus 2 to the infinity, which is infinity. And what does that mean, infinity over negative infinity? Well, at some point we're going to learn, what's it called? L'Hopital's rule. That can help with things like this. At least I think it can. I haven't studied it enough yet to know that. Pretty sure it can. But here's what I know. If I have fractions in which the bottom is approaching infinity, that part of the fraction is going to approach 0. So I want to manipulate this problem so that I have that. And to do that, I'm going to multiply the top and the bottom of the fraction by 1 over 2 to the x. This is really, really awesome. When we do that, let's see what happens. Distribute. Distribute this times the 5. You're going to get 5 over 2 to the x. Plus. Distribute. Multiplying something by its reciprocal gives us 1. Distribute on the bottom, we're going to get 1 over 2 to the x. Distribute on the bottom, we're going to get minus 1. Multiplying two reciprocals, you get 1. They're opposite signs. Now look how cool this is. Well, what does this fraction approach as x approaches infinity? It approaches 0. 1 approaches 1. It approaches 0 once again because the denominator grows so big that when you divide the number 5 by a huge number, it's getting closer and closer to 0. What does 1 over 2 to the x approach? It also approaches 0. So we end up with 1 over negative 1, which is negative 1. So we found that we had horizontal asymptotes at 5 and negative 1, which is answer E. Is there a faster way to do this? Probably. But I don't know how that is. All right, that finishes that.